Okay, hello. So don't mind my way I'm recording this right now. It's kind of a rigged version of trying to have like a doc cam. But we are doing 6.1, which is dealing with combinations. So a good way to explain the combination and kind of how we use this is when you think back to your old ISATs or PARCC tests, or when you even SAT and MAPS testing now, there's usually always a question on there that asks if you have in your closet 6 t-shirts, 4 pairs of pants, and maybe 3 pairs of shoes, how many different outfits can you make from that? So what you do when you have that problem is you likely don't know how to maybe solve it, but you find a way to solve it. Maybe back in the day by even drawing out a bunch of pairs of shirts and pairs of pants and shoes and trying to match them up. But essentially, you're trying to figure out how many different ways can you combine those 6 t-shirts with those 4 pairs of pants and 3 pairs of shoes. So the number of ways that they can be combined would here be your combination. Okay, so when we deal with combinations, order doesn't matter. It didn't matter if you chose that outfit first or if it was the second or third or last outfit you chose. Doesn't matter. It still counts toward one of those combination numbers. The way we write this and can insert into our calculator is when you have NCRs, how it's kind of written out, where N is the total number of whatever it is that you're dealing with, whether that be total number of shirts or maybe total number of apples, whatever it is, seriously. And R is going to be the total number of things you are choosing. So say I had 5 shirts in my closet and I'm going to choose 2 for the day, maybe 1 for a workout, 1 for going to school. That would be 5 is my total number in my N. 2 would be my R. Out of all the total shirts I own, I'm going to choose 2 of them. Okay, so 2 other huge words that come up are and or. So in these word problems, let's say I worded this as that I want to see how many different ways I can combine these 5 shirts and 2 pairs of pants. So and is signifying I'm going to multiply. Whereas or would be, let's see how many different lineups for the baseball game I can make out of all freshmen or all sophomores. Here, because that word or, we're going to add. Okay, so we have a word problem here. This is, there we go. And generally with some of these, I will give you even more details. In this one, I don't have a ton of details for you, but I can kind of explain them as we go. But given a standard deck of cards, how many 5-card hands can you make? So again, you don't have a lot of information about that deck of cards. A deck of cards contains 52 cards. This question is not asking us to narrow this down at all. They're not asking us to remove any cards or limit ourselves to a certain amount of cards. They're just saying out of the whole deck, how many different 5-card hands can you make? So because there's 52 cards in a deck, 52 will be my total number. Of those 52, I'm going to choose 5 of them. Okay, 52, total number of cards. This 5 is simply the number of cards I'm choosing because I need a 5-card hand. So the way you could put this in your calculator, and I apologize, mine is dead right now, so you won't be able to see much of it, but I can show you the buttons. You're going to go to the math button. Once you hit that math button, you will scroll over to something that says PROB, maybe it just says PRB, one or the other. Down to where it says NCR. Then you would essentially get a little box that pops up that you can put your 52 in, another little box that you can put your 5 in. If you press enter on this one, of course, my calculator is not going to work for me. Let me do something really quick. So we are getting, if we put this in our calculator, 2,005, no, 2,598,960. Okay, so on that side of, oops, there we go. Nearing that side of upper 2 millions there. Okay, so that's pretty insane. Let me get back to, there we go. Okay. So that's the answer to that one. Then we have how many 5-card hands of the same color can you make? Okay, so how many 5-card hands of the same color? We have to remember in a 52 deck of cards, 26 of them are black, 26 of them are red. Okay, so we're not going to just only take the black or only take the red. This now becomes a 2-part problem where we have to make 2 different decisions. When we make 2 different decisions, we have to have 2 different combinations here. So of the same color. So it's 5-card hand and it's of the same color. So because it's going to be an and here, there's no and written in there, but that's what you would say, right? You have to have 5 cards and they all need to be the same color. So we're going to multiply. The first choice we're making is what color are we choosing? So there's 2 different color choices and you're going to choose one. Again, you start with an entire deck in your hands every time. You are saying you're working with 52 cards, so you have to make that choice of taking half of them away at that moment. Then once we do that, we're left with only 26, in which of those 26 we will choose 5. Okay, so again, put that in your calculator. Let's see what we can come up with. All right. Sorry, guys, I'm doing this on my laptop. Giving us 1,300, 1,031, 560. Sorry, I was reading that off wrong. All right. Okay. So you can see a substantial difference here. Upper side of 2 million and then all the way down to 131,000 just because we take away half of that deck. Okay, essentially the same question here, but taking away half the deck makes the amount of possibilities much, much, much less. Okay, next one. How many 3-number passwords can you make on your bike lock? So this one's a little bit different. When we talk about passwords, the order technically does matter, right? If I put in 321 in my bike password, but the password was actually 123, that bike lock is not going to open up. It's a completely different password. Okay, so order matters, but I have 3 different digits to this password. So I can think of this as 3 different choices. Okay, I'm not limited to saying I can only use 1 through 5 or anything like that. So the assumption is that you can use numbers 1 through 9. And if you count those up, there's actually 10 digits. Zeros 1 through 9 amounts to 10 digits. So every single digit of this bike lock, all three of them, there are 10 total numbers you could choose from. We were never told that no numbers can be repeated or anything like that. So every time you go to choose a number for that lock, for that digit password on that lock, you have 10 total choices. You are going to choose one every single time because you can't choose more than one digit to be in you can't choose more than one digit to be on a double digit number to be in that single digit. Okay, and you can't choose more than one number to be in that single digit. Now, the other thing is, what kind of operation do we need between these? Because of the fact that we are using a bike password, you can consider this, that I can't use the word or. If I did, that would signify that I was saying that my bike password, instead of being 1, 2, 3, was 1 or 2 or 3 versus 1 and 2 and 3, right? All those numbers belong. Or signifies one or the other, whereas and signifies all of them together. So I need to multiply these together. Okay, so 10 choose 1, times 10 choose 1, times 10 choose 1. That should be coming out to 1,000 there. Okay. Last couple one of these. I'm not going to put these last ones in my calculator. I'm going to let you make sure you're doing these are all right. Okay. So if girls basketball team plays 13 home games and 12 away, how many sets of games can you watch of 3 home or 4 away games? So when we're looking at total, there are 13 home and 13 away. And I need to determine 2 different choices, what kind of home games I'm watching, what kind of away games I'm watching. I already know that there's this word or in here, which means I know I'm adding these. Okay, of all the 12 home games, I'm going to choose to attend 3. And of the, oh shoot, I mixed those up. I'm sorry. It's 13 home. And of the 12 away, I am going to attend 4 of them. Okay, so if you put that into your calculator, you would get the answer for that problem. Okay, last one, how many different ways can you watch 5 home and 2 away? So again, 2 choices. Because that word and, we have multiplication between the middle. Same thing, home, there's 13 total, but I'm going to choose to watch 5 this time. There's still 12 away, and I'm choosing to watch 2 this time. So find those 2 combinations, multiply them together. Okay, the gist of combinations is that regardless of what you're trying to combine here, there's different methods, different ways, focusing on that and the or, and essentially every time when you're dealing with a combination, you have to think of how many total choices are you making, and that's how many combinations you should end up with. Okay, that is it for 6.1.